Hello everyone, welcome to the video. My name is Gaurav J, and this video is about active, reactive and apparent power. We will also be looking in this video about the concept of power factor and power triangle. Okay, and this video is consists of only those points which are expected by the industrialist from an electrical engineer in this particular topic. Okay, so pay attention while watching this video. Okay, so this powers plays a major role in power system. Behavior of AC machines, transmission lines is easier to understand if you have the knowledge of active, reactive, apparent power rather than current and voltage. That's why this topic is important, and I'm pretty sure if you are going to pay attention for next few minutes, you'll be very clear about this topic. Believe me, you'll be very clear. Now, where you need this topic in industry. Okay, if you want to work as a maintenance engineer or in the field of energy management, or if you want to give exams of energy auditors or energy managers, you need to have the knowledge of this topic, because these guys are related to the power factor, and the concept of power factor comes from this active, reactive and apparent power. Okay, so that's why this topic is very important, and the most hot topic in the industry right now is power quality. Okay, so if you would like to work in the field of power quality, or if you want to study about the power quality, you need to have this topic very clear. Okay, so we'll get started with the topic. Okay, first of all, getting started, before you need to know that this topic is only related to the AC circuit and not related to the DC circuit. Keep that in mind. Only in AC circuit, because AC circuit is in the sinusoidal form, and we don't have any sinusoidal wave in a DC circuit. That's why it's not related to DC circuit. It is only related to AC circuit. Okay, so I hope this is clear to you, and now we'll get start with the topic, and the topic starts from instantaneous power. Okay, you need to know what is instantaneous power first. So to understand what is instantaneous power, we'll take an example. Let's say we have a circuit in which we have connected a battery and a lamp. Now I have to calculate the instantaneous power of this circuit. How to calculate that? Okay, it's simple. We just need to connect a voltmeter in parallel and ammeter in series. That will give you your instantaneous power. Now how? Okay, so the reading of voltmeter and ammeter gives us voltage of 12 volt and current of 2 amps. Okay, now to calculate the instantaneous power, simply multiply this voltage and current, and that will give us the power of 24 watts, and this 24 watts is nothing but your instantaneous power. Now why it is called as instantaneous power? Because we measure this power at the instance. Okay, that is why it is called as instantaneous power, and the unit of this power, of course, is watts. Now instantaneous power could be positive or negative. Okay, now you may ask a question, what is positive and negative in power? Power is power, right? So what is positive and negative power? We'll see that. Okay, now let us suppose if your power is flowing through source to load. Okay, like source is generator and load is something else, like a resistor or a motor. If your power is flowing through source to load, then it is known as positive power. Okay, and now if your power is flowing through load to source, then it is called as a negative power. Okay, now we'll get to this point, what is positive power and negative power in details. For that details, stick to the video. Now let's get to the part of active power. To understand what is active power, let us assume that you have a generator and you have connected it to the load, which is resistance in this case. Now to understand what happens exactly in this circuit, we have drawn two waveforms for voltage and current. Okay, the blue line, blue waveform shows the voltage, and the yellow one shows the current. We know that in resistive circuit, voltage and current are in phase. That is the basic thing. Okay, now what happens the both the waveforms are in they are having its own positive peak, then zero value, then again negative peak, then again zero, and then again positive. This is the flow. This is the basic flow. Now if we have to calculate the power, let us say in on this instance, okay, what we will do, we'll simply multiply this voltage to this current. Now both the values are in positive side, so the answer definitely will be a positive value. Okay, now let's as suppose that we have to calculate the power at this instant. We also need to multiply this voltage to this current, and both negative multiplied by negative will give you a positive value. Okay, now here also the same, you will get a positive power. So the conclusion is, in active or in a resistive circuit, the power will always positive. If you draw a waveform for it, shows the red line, you will get the waveform only in positive side, and this line shows your active power. Okay, active power is always positive power, and positive, it means your power will only flow through generator to the resistor. Okay, there is no direction change here, it is only positive, and it will flow only through generator to resistor. Okay, I hope this is clear to you. And now let's see some basic properties of active power. It is always positive, yeah, it does not changes its direction. The power only stays in the positive side, it never goes to the negative side. Okay, what is negative side we will see in a few minutes. Okay, so power flow is always from source to the load. Okay, there is no reverse flow, it only flows through source to the load. Okay, now let us see about the reactive power. To understand what is reactive power, let us again suppose that we are having a generator, and now we have connected it to an inductor instead of a resistor in the last case. Now what really happens in the circuit? Okay, so to get into that detail, we have drawn some waveforms. Here you can see them. The blue line shows the voltage, the red dotted line shows the current, and the green line shows the power. We know that in inductor, current lag behind the voltage by 90 degree. Okay, it is the basic thing again. Okay, so if you want to calculate power at this instant, you have to multiply this voltage. The voltage is positive here, and the current, which is negative here, it will give you a negative value. Okay, right? That's why it is a negative peak. Okay, if you want to multiply, calculate the power at this instant, we will be multiplying these two values, which is positive, and that will give you a positive value. Again positive, negative, negative, again negative, negative, positive. Okay, so this is, so what exactly this positive peak and negative peak of power means. Okay, so let's see that. During your negative peak, what happens, your power flows through inductor to generator. Okay, that is the negative peak. And now what happens during the positive peak, your power flows in the normal direction, which is from generator to the load or to the inductor. So in this case, the power is flowing back and forth. Okay, the power is going and coming back again, going and coming back again. So power that surges back and forth in this manner is called as reactive power. Okay, reactive power, and symbol is Q. Okay, now why this happens, the positive and negative peaks, why this happens? To understand that, let's see this. Okay, now let us suppose you are having your positive peak. Now what happens during this? Inductor stores energy during the positive peak. Okay, it stores energy in it because this is the property of inductor. Okay, now what happens during the negative peak? The stored power is released by the inductor. Okay, that's why we are getting a positive and a negative peak, and this kind of power is known as a reactive power. Okay, and this is generally caused by the instruments like inductor, capacitors, or the nonlinear devices. To measure the reactive power, you can use a meter called VR meter, which is available in market. directly by connecting that meter into the circuit, you can directly get the reactive power, consumption of reactive power, the generation of reactive power. Okay, now let's coming back to our waveform. Here you can see every positive peak is followed by the negative peak. Okay, the energy flows back and forth between the generator and the inductor without ever being used up. Guys, this sentence is very, very important. Hear it again. Okay, the energy flows back and forth between the generator and inductor without being used up. Okay, so this energy is not used in the useful work because it flows and then flows back again, flows and flows back again. Okay, what is the reason for this positive and negative energy surges? Okay, the energy flows back and forth because of the magnetic energy is alternately being stored up and released by the reactor. Okay, it is happening because of your reactor. Thus, when power is positive, the magnetic field is being built up by the inductor. A moment later, when the power is negative, the energy in the magnetic field is decreasing and flowing back to the source. Okay, when you are having your negative peak, the power stored by this inductor is released and that energy flows back to the generator. Now let us see some of the basic properties of reactive power. It has a positive and negative peak. Yes, it is not used for useful work because the power is surging back and forth without, which is not used by the system. That's why it is not used for the useful work. It is measured in VAR. VAR means volt ampere reactor. Now let's see the basic comparison of active and reactive power. One cannot be converted in other. You cannot convert your active power into reactive and vice versa. They are treated as a separate quantity. Active power is a separate quantity and reactive power is a separate quantity. Remember that. Both place a burden on the transmission line. It doesn't matter if your transmission line is carrying active power or a reactive power. It will place some burden on that line. Active power produces heat, mechanical power, light, torque, etc. Okay, while reactive power only represent power that oscillates back and forth. Your reactive power is not useful for the production of heat, mechanical power, torque or light or anything else. Okay, but it doesn't mean that you don't need reactive power in your system. Your transformer, induction motors, magnets, ballast, they need this reactive power to produce the AC magnetic field. Hear it again. Your transformer, induction motor, ballast, magnets, all the magnetic device needs reactive power for the production of AC magnetic fields. And without AC magnetic field, your device will not work. Okay. So up till now we have seen about the active power and the reactive power. We have known that resistive load will consume active power and inductive load will consume reactive power. Now the interesting thing comes here. Now what happens if my system is consist of both resistive load as well as active load? What will be the power in that case? Okay, and this point will lead us to our next topic, that is apparent power. Now let's just see what happens if my system is consist of both the loads, that is resistive and inductive. Okay, these both the load will draw different current. My resistive load will draw a current IR and my inductive load will draw a current IL. Okay, now if you connect a wattmeter to measure the power in the circuit, you will get a power in watt, and that is definitely will be the wrong answer. The reason is your resistive load is drawing active power and your inductive load is drawing a reactive power. So to calculate the power of this, you need to have both of this power, and the combination of this power is known as apparent power, and it is symbol is S. You got that? The combination of both active and reactive power is called as apparent power. Okay, and it having simple relation between active power, reactive power, and apparent power. And it is given by S square is equals to P square plus Q square. S is nothing but the apparent power, P is active power, and Q is a reactive power. Okay, and the unit of apparent power is not watt, it is also not kVAr, it is volt ampere, or VA, or kVA kilovolt ampere, or MVA mega volt ampere. Now I hope all these powers are clear to you, and now we will see the most interesting part in this topic, which is power factor. Now if you ask anyone what is power factor, you might get this answer. The power factor is nothing but the ratio between, or angle between, the voltage and current. You'll get this answer. And guys, I'm requesting you, please drop this definition. It might be correct, but it is not the proper definition. Okay, so what is the proper definition or proper meaning of power factor? Here it is nothing but the ratio of active power to the apparent power. Okay, power factor is equal to active power divided by apparent power. Okay, use this definition. This is the proper definition and the proper meaning of power factor. Okay, now if you see the nameplate of any induction motor, or in like say transformer, you'll find it on a nameplate. Here the power factor is written. Let us say I'm having an induction motor, and on my induction motor it is written as 0.8. Now what does this 0.8 means? What does the power factor is equals to 0.8 means? So it means my induction motor is consuming 80% of active power from the 100% of apparent power. Okay, simple power, and the remaining 20% is reactive power. Okay, now what if it was 0.9, then it means 90% of active power and 10% of reactive power. Now if it was unity, then it means 100% of active power and 0% of reactive power. So that is why the power factor is important. Now to sum up, the power factor of a circuit or device is simply a way of stating what fraction of its apparent power is real or active. Okay, now the power factor is said to be lagging. Okay, there are two types of power factor, lagging and leading. The power factor is said to be lagging if the current lag behind the voltage, and this is in the case of inductive load. Okay, like transformers, induction motors, etc. And now the second type is leading. The power factor is said to be leading if the current leads the voltage. Okay, and this is the case of capacitive loads like capacitors bank or a single capacitor. Okay, I hope the concept of power factor is now clear to you. Now let's just see about the power triangle. Okay, we have seen the relationship between the active, reactive, and apparent power by an equation, which is S square is equal to P square plus Q square. Now that expression can also be shown by using a triangle, and that triangle is called as a power triangle. Okay, now your active power is shown by a horizontal arrow. Okay, and the reactive power consumed by your circuit is shown by the vertical arrow Q, and the addition of this is shown by the different arrow S. Okay, now this is your power triangle. This is a famous question in technical interview, draw power triangle or show me the powers on the different sides. So you always have to remember that the horizontal line is always active power, the vertical arrow is always a reactive power, and addition of these two is apparent power. Okay, I hope this is clear to you guys. Let's take a quick recap of up till what we have seen. Okay, instantaneous power is the power which we calculate at any particular instance. It can be positive or negative. The power which always remains positive is called as active power. It never changes its direction. The power which only oscillates back and forth without being used up is called as a reactive power. Apparent power is the combination of active and reactive power, and it is given by, or the relationship between active, reactive and apparent power is given by S square is equals to P square plus Q square. Remember this equation, this is important. And power factor is the active power divided by apparent power. Okay, this is the formula for power factor. So I hope whatever I have explained in this video is clear to you guys, and subscribe my channel for more videos. Keep watching, keep learning.